Hello. Hello. Hello.
அவ்வளவுதான் வரும். அது தாண்டாது.
يرحمك الله.
Ne diyorum? Tuğyeni.
Hmm. Hmm. Evet. Dear participants, sorry for the inconvenience. The session will start shortly. Hello, am I audible and visible? Hello.
Yes, ma'am.
Yes, madam.
Okay. So, respected chief guest, esteemed resource persons, honorable dignitaries, faculty members, and dear participants, a good evening to one and all. It's my pleasure to introduce our distinguished resource person for today's session, Ms. Anju Paul, who is currently pursuing her PhD in ultra high performance concrete at the Research Center, Athanasius College.
सही बात अपना काम सक्सेस हो जाए इसलिए जा रहा है अपन कोई घूमने फिरने थोड़ी
Engaged in a doctoral research since November 2021. Her research work titled Ultra High Performance Concrete is being carried out as a part of a Kerala Highway Research Institute funded project in collaboration with IIT Madras, IIT Tirupati, and NIT Calicut. She completed her Master of Technology in Structural Engineering from Karunya University in 2010, securing first rank with a distinction, and earned her Bachelor of Technology in Civil Engineering in 2007 from Athanasius College of Engineering. She is serving as an assistant professor at Athanasius College of Engineering, a position she has held since July 1, 2025. Prior to this, she worked as a project associate at the same institution from March 2023 to December 2024. Earlier in her career, she served as an assistant professor at Tokach Institute of Science and Technology from June 2010 to August 2022, where she played a key role as the department coordinator for NBA and NAC accreditations. She is also a two-time recipient of the Best Teacher Award, having received the honor in 2014 and 2019, and has coordinated several international conferences, national seminars, and faculty development programs. Then she began her academic career as a lecturer at Mar Basilius Christian College of Engineering and Technology. Then her academic and research interests include concrete technology, structural analysis, structural design, and modern construction materials. Then she has successfully published 21 research papers and delivered 3 conference presentations. She is a lifelong member of the Indian Concrete Institute and has served as a
Hi all, good evening all. Am I audible?
Yes, ma'am.
Yes, ma'am.
Audible.
Audible, audible.
Is it visible?
Yes, ma'am. It's
Yes, ma'am.
visible.
Visible, visible.
Okay. Then good evening all. Thanks for the nice introduction. As you heard from my introduction, I'm doing my research in ultra high performance concrete. Nowadays, most of you know the most of the research focus on the UHPC, the development of UHPC and the performance of UHPC. My research area, actually, I'm focusing the development of UHPC by using the locally available materials. That means available in the Indian market. As an introduction, actually, in the last 2 decades, we have seen so many floods, earthquakes, and infrastructure failures causing not just economic loss, but loss of human lives. As the civil engineers, we must ask ourselves, are our structures part of the problem or part of the solution? During disasters, we often see 2 types of structures side by side. One collapses and other survives. The disaster is safe. The difference is the material, the design philosophy, and the preparedness. The disaster cannot be prevented, but the impact can be reduced. One of the major lessons we can we can learn from the disaster is the construction materials often fail due to cracking, falling of the concrete, and many durability issues. All this has led to the development of some advanced materials like UHPC. UHPC is a material that helps to control the damage. As the definition, actually, according to ECI, the high performance concrete is defined as the concrete It's defined as the concrete is a special combination of performances and the requirements that cannot be achieved by using the conventional concrete and conventional curing practices. UHPC is a cementitious composite material showcasing exceptional mechanical characterization and the durability properties. All this performance can be achieved by incorporating the high strength steel fibers. We are considering only the fine aggregate, we are neglecting the coarse aggregate and the binders, chemical and the mineral admixtures and water. The UHPFRC, actually, UHPFRC means ultra high performance fiber reinforced concrete. It is a combination of 3 types of concrete. One is high performance concrete, one is self-compacted concrete, and the third one is fiber reinforced concrete. The mixture of these three is the ultra high performance fiber reinforced concrete. Mainly the basic requirements of ultra high performance concrete is actually, in order to get the high performance, we need the high binder content. As you all know, because of the high binder content, that means high cement content, that will negatively impact the sustainable aspect. So we have to reduce the cement content by considering the some of the mineral admixtures or supplementary cementitious materials of high pozzolanic material content. The high performance of the UHPC can be achieved by considering the low water to cement ratio. We have considered the water to binder ratio as the 0.17, 18, and 19. And by considering the low water to binder ratio, we cannot achieve the required flowability. The main criteria we are considering the ultra high performance concrete are the compressive strength beyond 120 MPa and the flowability is the minimum 200 mm. Since it is, as I said earlier, it's just like a self-compacted concrete. In order to get the flowability of 200 mm with the low water to binder ratio of 0.17 and 18, it is very difficult to achieve the flowability of 200 mm. So in order to get the flowability of 200 mm, we have to consider high-end superplasticizers. We have considered PCE-based superplasticizers. Then in the case of high normal conventional concrete, not to achieve the high strength like above the 120 MPa, the material will behave a brittle nature. To avoid that nature, you have to consider the fiber in order to change the character from the brittle to ductile nature. We have incorporated good quality fibers. Then to achieve the very excellent performance, actually we have considered the maximum packing density. That means the minimum pores. The normal conventional mixing procedure or normal conventional mix design cannot be appropriate for the development of UHPC. So we have considered some optimum mix design. The curing practices are normally from the literatures and from our experience. Actually, there are three types of curing practices we can be adopted. The normal curing, that is the water curing. Mainly in the case of UHPC, we have considered heat curing. Heat curing means there are different types of heat curing, the hot water method and the steam curing. We have followed the steam curing. If you compare the properties of normal concrete, high performance concrete and the UHPC, in the case of compressive strength, normal concrete, as you all know, the compressive strength is in between 20 to 50 MPa. If it is in the case of high performance concrete, it is in between 60 to 120 MPa, but in the case of UHPC, it is above 120 MPa. Similarly, the flexural strength also, if it is a normal concrete, 3 to 5 MPa, in the case of UHPC, it is around 20 MPa. In the case of tensile strength, in the normal concrete is 2 to 5 MPa, but in the case of UHPC, it will be up to 15 MPa. Modulus of rigidity, modulus of elasticity, modulus also the 25 to 34 GPa in the case of normal concrete, but in the case of UHPC, it will go up to 50 to 60 GPa. If you are considering the historical background of UHPC, as we are familiar with the development of Portland cement in 1824, from that 1824 to development of HPC, that will be in that was in 1970, and the UHPC was firstly introduced by Lerard in 1994 until the UHPC today. To develop the UHPC, we have considered these 5 criteria: the material characterization, optimum packing density, mixing technique, fresh UHPC state, and the curing methods. In the case of material characterizations, we have considered the binders and fillers. Fillers is used to improve the particle packing density, and the fibers is to get the ductile behavior. Then some supplementary cementitious materials are tried, superplasticizers, fillers, fine aggregates, and the fibers. To get the optimal particle packing density in the case of laboratory experiment, we have considered the Punke test. And by using the software, we have considered the MR software that is based upon modified Andreessen and Anderson model. The MR software, it is developed by Elcom. That will be discussed later. The mixers we have in the laboratory, we have used the Hobart and planetary mixer, and also we have done that experiment. Then we have developed the UHPC with the 150 MPa by in the high shear mixer, that is an RMC. Flowability we have considered, as I said earlier, minimum 200 mm. There are three types of curing methods: standard, heat, and autoclave curing. But in this case, we have considered only standard curing and the heat curing method. UHPC needs superior mix design, high binder of cement content, low water content, high-end superplasticizer, fiber addition, and the curing method. By considering the heat curing, we can enhance the microstructure by that heat treatment. In order to obtain the high performance, as I said earlier, we have to consider the maximum particle packing density. That has to be achieved by optimizing the granular mixtures. We have considered so many parametric study by varying all the constituents to develop the UHPC. And finally, we have arrived at some optimized granular mixture. Then we can enhance the homogeneity by the elimination of coarse aggregate. Also, we can reduce the weak section in the ITZ zone. Then we can enhance the ductility behavior by incorporating the steel fibers. By adding the steel fibers, what actually happens is that it will bridge the. If you are considering the sustainability aspect of UHPC, by considering the UHPC, we can reduce the cross section, or we can that will be the slender structure. By reducing the cross section of the structures, we can improve the aesthetic appearance, as well as we can reduce the environmental impact issues. Then in order to get the high performance of a concrete, we have to consider the high binder content, that means the high cement content. To reduce the carbon dioxide emission or to get the green and cleaner product, we have to optimize the UHPC by considering some of the supplementary cementitious materials. In our study, we have considered alcofine or ultrafine slag, GGBFS, and the silica fume. Then, as I said earlier, we can reduce the cross section of the structure. If you are considering the conventional concrete, if we need the depth of the concrete like this, if you are considering mainly the UHPC application will comes in the case of girders. If you are considering the depth of the girder, in the case of conventional concrete, that depth of the girder can be reduced by using the UHPC, since our strength is too high. In the case of conventional, by comparing the conventional concrete and the UHPC, I have said earlier the particle packing is too good. It is having minimum pores in the case of UHPC. By minimizing the pores, the particle packing density can be improved. By improving the particle packing density, we can enhance all the mechanical characterization as well as the durability properties. Also, we can reduce the depth of the section. That means we can introduce the slender cross section. So the main benefits of UHPC, we can reduce the cross section, we can reduce the maintenance, we can improve the ductility behavior. Since the reduced maintenance that can achieve the longer life, then the improved strength, we can reduce the cost. Actually, the initial cost of the UHPC development is too high because of the material and the curing method and all. But if you are considering as the project as a whole, by considering the maintenance part and the durable part, then we can save the economic. Then by considering the supplementary cementitious materials, we can reduce the carbon footprint, and it is sustainable. The main applications of UHPC is in the highway infrastructure, bridge decks, as I said, bridge girders, seismic columns, accelerated bridge constructions, wind turbines and tunnels. The particle packing density. The performance of a concrete mix can be optimized by the packing densities. The packing density has a great impact for the performance of the concrete by considering the lower water to binder ratio. Then we can reduce the permeability and we can reduce the porosity also. In the case of particle packing density, the major factors affecting the particle packing density that are the size and grading of aggregates. If you're considering the MR software, the main inputs are the size of the aggregates, the effectiveness of there is a one factor, that is effectiveness. We are providing the 0.23 to 0.27 for the finest particles, and the compaction process is the mainly affect the particle packing density. But since it is a self-compacting concrete, we are not providing any type of external vibration. We are 3 seconds of external vibration only. Improving the particle packing density, we can reduce the amount of cement, and that leads to the that can reduce the carbon dioxide reduction. This is the one of the example for the MR software graph. By inputting the aggregate size and the effectiveness index, then we will get the modified Andreessen model that is in the red color. That is the good particle packing curve. Then if we add in that software our mixes, that is I have inputted the M1 mix, M2 mix, and M3 mix, and M4 mix. If you are incorporating here, if we are adding our mixes, then that will be in like this. These gaps that will shows that size of particles are missing here. Maybe we can increase the in some cases we can increase the size of the particles. Well, we can increase the quantity of the size of particles, or in some cases we can reduce the quantity of that size of particles in order to fit that curve into the modified Andreessen model. So what we have done is, firstly we have considered the MAA model, then we have considered so many trial mixes and put into the MR curve and find out and check the graph. Then we have modified that mix design by considering this graph. If you are considering, if you have gone to the disaster management phases, mainly there are 5 phases in the disaster management: prevention, mitigation, preparedness, response, and recovery. But UHPC plays a role mainly in the prevention, mitigation, preparedness, and the recovery. Then from this FPP, also you all know, the mitigation means the reducing damage before a disaster occurs. The problem with the conventional concrete is the sudden collapse or the brittle nature during the disaster. Here, how the UHPC help is, UHPC has very high compressive strength, tensile strength, and the strain hardening behavior. This allows the structures to sustain the extreme loads with the controlled cracking instead of that blast behavior or the sudden failure. Then preparedness means the designing the structure to perform under the extreme conditions. By providing the thin sections, we can reduce the dead weight. Due to that high stiffness, we will get the less deformation, and it is having the excellent fatigue resistance also. In other way, UHPC structures are not only the strong, but also the smartly prepared. They absorb the energy instead of collapsing. In the case of recovery, it is not just rebuilding what was lost. It is the rebuilding faster, stronger, and smarter. In the conventional concrete, after a disaster, repair often comes, long curing time. There is a thick section, repeatedly maintenance required. But in the case of UHPC, it is having high early strength. We need only thin repair sections and excellent bond between the existing concrete. The damaged bridges and slabs can be reopened in days instead of months. Instead of demolishing a damaged structure, UHPC enables us to recover its load carrying capacity efficiently. Also, the repaired structure does not fall again because it is having high properties. Then if you're considering the UHPC projects already, the first UHPC bridge that is in China with a compressive strength of 200 MPa, it is a bridge, 6.6 meter wide, 70.8 meter long, and 5.4 meter height. The slab thickness is 0.2 meter. Depth to span ratio is only 1/28. Then the India's first UHPC bridge that is in Maharashtra. UHPC, they could be reduced to the self-heat by 30 to 35% than the conventional concrete with a strength of 155 MPa. Then in the case of Mumbai GCC clubhouse, it is also 8.4 long UHPFRC. Then only 3 to 12 mm diameter rebar they have considered. In that case, also the self-heat that could be able to reduce by about 30%. The main challenges in UHPC actually was the short history of worldwide field application. Maybe because of the high material cost and high equipment cost, the high initial cost. But mainly what I felt is that it is mainly because of the lack of any guidelines, the lack of code of practice for the structural use of UHPC. And the one of the main other reason is the lack of experience in the local engineering society. This is our main focus area in the research. Can we develop the UHPC with locally available materials? When we have gone through the literatures, we have seen the UHPC production in majority in Canada, China, USA, and all. But with that locally available materials in the Indian market, can we develop the UHPC? That's our main focus area. As they said, the project team is actually this is a funded project by Kerala Highway Research Institute in collaboration with IIT Madras, IIT Tirupati, and NIT Calicut and MEES. 1 minute. Hello. Hello. Oh. This is our project team. What are the research concrete, M150 concrete and M175 concrete using the locally available materials? And we have developed some mixing guidelines. That means that there's no the conventional mixing practices cannot be appropriate in the case of UHPC. So we have developed the mixing guidelines to develop the above mixes. Then to develop that above mixes M100 to 175, we have considered so many parametric studies by varying so many constituents to develop the UHPC. Then with the developed mixes, we have considered the mechanical characterization, fracture parameters, stress strain characteristics, and the modulus of elasticity. Also the durability characteristics also we have studied. The main materials we have considered is that we have considered the ordinary Portland cement of 53 grade. Supplementary cementitious materials is alcofine or ultra fine slag, GGBFS, and microsilica. We have considered densified as well as undensified microsilica, but I think the microsilica undensified works well. Superplasticizers PCE based we have considered. We have considered steel fibers with aspect ratio 100. Then we have considered M sand, cord sand, river sand, standard sand, all. Filler, in the case of filler, we have checked with the quartz powder and limestone powder, but finally we have agreed with the quartz powder. Then what type of curing we have followed is that in the case of parametric study, we have considered so much curing temperatures like 90 degrees centigrade as well as 60 degrees centigrade. And also we have varied the delayed period. That means after the casting, after 24 hours of casting, we have demolded the specimen. Then delay period means when it has to be put in the case of put into the steam curing after. Then we have considered 24 hours delay period, 48 and 72 hours delay period. Within that, with all this, we got the 48 hours delay period shows the better performance. Then also the curing period. That means in the case of a accelerated curing tank, we kept all the specimens in 24 hours, 48 hours, and 72 hours. From all the research, we agreed that the 48 hours curing period got the best results. How we put in the heat curing is that in the case of an accelerated curing tank, there are 2 layers in that. There are 2 layers. In the first layer, up to the first layer, we kept the water. and then put that water into the 90 degrees centigrade for 48 hours. Then the second layer we have put the specimens in 48 hours. Finally, we have reached the mixer 125, 150 and UHPC mixtures. In the case of 125, we have considered 20% of 21% of supplementary cementitious materials, 1.5% of fiber, and it is 38%. There is only 1%. Then the SP and water is in the 19%. Then in the case of M150, these are the percentage. M175, these are the percentage. And before not putting the mixed design, actually the work is not published. Actually, the one or two papers with the published. That's why I have put that values in the percentage. After all the parametric studies, what we have, our findings are, we have considered so many ordinary Portland cements. That means a different brand of ordinary Portland cements. Then we found that we can use any type of ordinary Portland, any brand for ordinary Portland cements. That all works very well. In the case of sand, we have considered standard sand, coarse sand, river sand, and the manufactured sand. The best results we got is from the standard sand, coarse sand, and the river sand. We could reach only up to the 150 MPa with the M sand. But due to the availability of standard sand and the river sand, finally we move on with the coarse sand. Then in the case of fiber content, we have considered the parametric study as we have varied the dosages of fibers and we have varied the aspect ratio of fibers. Then finally what we have reached is, as we increase the dosage of the fibers, that will increase the performance characteristics, but that will negatively affect the flowability. I will show some figures with that. The proper dispersion of fiber that enhances the properties of the UHPC. Then as we increase the aspect ratio also, that will increase the performance of the UHPC, flexural as well as the compressive strength also. But in that case, that will be only up to the 100, aspect ratio of 100. So we have considered the 20 mm straight steel fibers with the 0.2 mm diameter straight steel fibers, and we have compared that with the 13 mm fibers, 13 mm long fibers with the 0.2 mm diameter fibers. Then from all the studies, we have concluded that the 2% of 13 mm fibers will show the same results with the 1.5% of 20 mm straight steel fibers. Then optimum gradation of constituents that helps to improve the results. We have considered Punke test as well as the MR software. In the case of heat curing, we have considered the different delay period, different curing temperature, different curing period. That all affects the properties of UHPC. And what we follow is that 90 degrees centigrade with the 48 hours delay period with the 48 hours curing period. These are the mix. As I said, it's just like a self-compacting concrete. It is around the 200 mm. Then from like this, it will follow. The flow is like this. Then we have considered the high shear mixer that is in the RMC plant. And in the laboratory case also, we got almost the same consistency. This is the RMC plant. Actually, the flow is so this is very high density flow. The density of fresh UHPC was 2. At that time, that was unpredictable for us. To do the experiments, we have servo-controlled machines. Servo-controlled machines we can collect the details after the post-peak behavior. That is the main advantage of this servo-controlled machine, because if you are considering the FRC, fiber reinforced concrete, after the post-peak, the they can control the crack. So the main behavior that will be up after the post peak point. Then this is what I said earlier. If you are increasing the dosage of fiber, that will enhance the properties of the UHPC, but that will negatively impact the workability part. Negatively impact means there will be a fiber agglomeration. There will be no proper dispersion of the fibers. Without the proper dispersion of the fibers, we cannot get the good results. So from this only we have, this is the 20 mm straight steel fiber. From this only we have adopted, by considering both the criteria. Both the criteria is both the compressive strength and the flowability part. In the case of flowability, the 1.5% shows the better results, better dispersion of fibers. So cube without fiber and the cube with fiber. The cube without fiber, as you know, that is a brittle nature. That means the failure will be the sudden failure. Will get the cup and cone shape. But in the case of cubes with the fiber, that will control the cracking pattern, that will be control the failure pattern. That means the ductile nature will occur. This is the cube with fiber. This is a flexural testing machine, the crack propagation pattern and all. The servo controlled machine. This is how the crack pattern occurred. This is not the sudden failure, that will be the ductile nature. That is all the fibers that will bridge the crack propagation. Then when we consider the stress-strain relationship, or to consider the flexural strength behavior, then after the post-peak behavior, in the case of conventional concrete, there will be a sudden drop occur in the case of normal concrete. But in the case of UHPC, due to the presence of fibers, after the post-peak point, there is no sudden drop. There will be a controlled damage or controlled crack pattern will occur. This will be the pattern occur in the case of stress-strain relationship or the flexural strength pattern of the UHPC specimen. In the case of normal concrete, the flexural strength is 3 to 5 MPa, but we got in the case of UHPC, it is 16.9 to 28.6 from the 120 concrete to M175 concrete. We are considering the fracture parameters also. There will be the fracture toughness, the very high increase in the case of fracture toughness by using the UHPC. In the case of your elastic modulus, to find out the elastic modulus of the developed UHPC mix, we have considered the servo control machine itself, and we have considered 3 stages, and there is a cyclic and uncyclic, the loading and unloading. Then in the first 3 cycles we have considered if the 150 concrete, that the stress is, we have expected stress is 150 Newton per mm square. The first 3 cycle, that is 1/6 of the expected strength, and the last 3 cycles that is the 1/3 of the expected strength. Then by using this, we got the M125. The E modulus of M125 is 47.945 gigapascal. M150 is 49 gigapascal. M175 is 55 gigapascal. We have followed the CN12390 code. We have also checked a slab, a UHPC panel also with the size of 60 centimeter. Then that has checked by using the servo controlled machine. And as part of durability studies, we have conducted the water absorption, sorptivity, acidity, acid attack, and sulfate attack till now. And in the case of water absorption, we have considered the 90 by 100 mm. Then sorptivity 100 mm diameter and 50 mm chord from the 150 mm cube. The case of acid, 50 mm thick slice of 100 mm nominal diameter cylinder. Then in the case of acid attack and sulfate attack, the 150 mm cube. These are the results by comparing the normal concrete and the UHPC. In the case of durability studies, the water absorption is too low when we compare with normal concrete. It is only 0.7. Sorptivity index is 0.65. RCPT in coulombs is 108 coulombs only, but in the case of normal concrete, it is 2200. Acid attack and sulfate attack, weight loss is only 3.6 in the case of UHPC and 0.828 sulfate attack weight loss in the case of UHPC when compared to normal quantity is 1.93. We consider the shrinkage, we have considered only the drying shrinkage and the autogeneous shrinkage only. With the specimen of 280 by 20 by 20 mm specimen. In that case, we have considered the heat curing and the normal curing of heat curing and normal curing in the case of shrinkage. Also, the inclusion of fibers and without fibers, what will be the effect in the case of UHPC we have considered. When we compare the normal quantity and the UHPC in the case of a shrinkage pattern, the value is cannot compare the value. That means in the case of normal concrete, it will be go up to the 600 microstrain, but in the case of UHPC, it has go up to only 90 microstrain. These are the shrinkage characteristics, shrinkage mold and the shrinkage specimen. As part of that funded project, finally we have concluded that project with the casting of girder with a 6-meter span. Then we have considered 4 girders to compare the properties. Firstly, in the case of normal concrete, we have considered the rectangular cross section as well as the eye section. And the next 2 girders are, one is with the UHPC alone and one is with the UHPC with the steel bars. We have considered 4 girders. Actually, I think it was the first largest production of UHPC in Kerala. That was in Kodamangalam RMC plant. These are some pics of that girder casting. This is our team. These are that girders with a 6-meter span. The one is with the UHPC and one is with the UHPC with the rebars. And the normal concrete, we have developed that normal concrete. We have cast the normal concrete in the campus itself. What are the main challenges we have faced in the girder casting was high density mix. As you see in that flow of the UHPC mix, fresh UHPC mix, the density of that fresh UHPC was too high. So in the first time, that was unpredictable for us. When that flow comes, actually the formwork was is washed out actually. Then that was a very big failure the first time. And the second time, we have reworked in that formwork design and we have considered so many bracings in that. So that's why only we can support that fresh UHPC mix, high density UHPC mix, because that happened only with that redesigned formwork. Then the optimum mixing procedure, that means till that point we have considered only the laboratory procedure. In the laboratory procedure, what we follow is that initially we put the aggregate and the binders and mix it for 2 to 3 minutes to get the proper dispersion of the silica fume. And after that, we have considered actually in order to control the initial heat of hydration due to the very low water to binder ratio, we considered ice particles, ice cubes to control the initial heat of hydration. So 80% of ice cubes we have initially considered. After getting the very good mix of the binders and the fine aggregate, we have added the 80% of ice cubes and continuing the mixing procedure for 5 to 6 minutes. Then after getting some moist mix, then only we have put the 20% of cool water plus the superplasticizer blend into that. Then after the addition of SP and all the water, then again continue the mixing for another 2 to 3 minutes to getting the proper mix. After getting the proper consistency, then only we have added the fibers. After ensuring the proper dispersion of fibers, for that we have mixed around 2 minutes more. Then only we have cast the specimen. After casting the specimen, cover the specimen with the plastic sheet, because in order to avoid the moisture loss, since the moisture content is too low in the case of UHPC. That's the laboratory practices. But when we came to the RMC plant, that was not work. So we did the so many trials in the RMC plant and identify a optimum mixing procedure there to develop that girders in the RMC plant. Then next challenge is the determine the time between the mixing and placing. After mixing from the RMC mixer, that high shear mixer, the girder formwork of the girder, we have to put that mix into the girder. That lapse time with that the retention time. So before that, what we did is we in the laboratory itself we have found out what was the retention time we will get by using the UHPC that mix. So we found that around 1.5 hours to 2 hours retention period we will get after the addition of water in the case of UHPC. Then to get that 6-meter UHPC girder, it has done, I think, around 3 batch of product, completed by considering 3 production batches. So to get the consistency mix properties with that production batches, that was the next major challenges we have faced. Then after the 28 days, we have tested the that girder, all the 4 girders. We got around 700 kilonewton in the case of UHPC alone. But when we consider the UHPC with the rebars, actually we didn't get the accurate results because when we load that UHPC with the steel bar girder, the loading pressure pump was blast. So we cannot actually there was only a small just a little bit crack was only happened in that case of UHPC with the steel bars girder. So that didn't fail in that testing. I've tested all the 4 bars. This is the reinforced UHPC bars actually. That will, in the case of UHPC, there will be small deflection occur initially, but after the releasing of the load, that will regain its original shape. That was happened at that time. There is only the little bit crack occurred in that girder. It went beyond the capacity of the loading frame. So we tried again. It also happened the same. And we have considered the normal concrete with the rectangular cross section as well as the I section. This is our reinforced UHP FRC. Actually, there is only a small crack occurred here. That only happened in that UHPC reinforced girder. And this are the team actually. This much work was done in the maze in the case of UHPC. Then thank you all for the patient hearing. Then if you having any query, you can ask. Actually, I have not completed my thesis. Then hopefully next year I can complete this.
Ma'am, there is a question in chat box. How can UHPC enhance the disaster resilience of critical infrastructure such as bridges, hospitals, and emergency shelters?
That's what I said earlier. Actually, by considering the UHPC, we can prevent more what we said. We can prevent the more damage occur due to that disaster by considering the high compressive strength and high durability properties. The and why we can reduce the impact. That's what distinguishes the high performance concrete from the conventional high performance concrete in the case of composition and the behavior. Behavior, as I said earlier, I have shown one table there. The composition actually, when we consider the constituents to prepare the HPC, firstly, initially what we, when we develop the HPC by considering the different parametric studies, when we consider the, we can reduce the cement up to, in the case of UHPC, we need to increase the cement content up to around 900 kilogram per meter cube in the case of 1 meter cube concrete. But in the case of M125, below M120 concrete, we need only the cement content up to 450 to 500 kilogram per meter cube. Then we can reach the HPC or up to 140 MPa. We can reach by considering Alcofine, GGPFS and all. But in order to get the above 140 or not to reach the 150 MPa, we required actually microsilica. The one of the major factor is silica field to reach that strength requirement. To reach the M150 concrete, the compulsory requirement is actually we need microsilica, we need steel fibers, we have to avoid the coarse aggregate, we need to increase our binder content to 1100 to 1200 kilogram per meter cube. We need to increase our binder content. We have varied the binder content from 900 and 1,600 kilogram per meter cube. What happened is that after 1,200 kilogram per meter cube, or we have also varied the cement content from 500 to 900 kilogram per meter cube. When we increase the cement content beyond a particular limit, or when we increase the binder content beyond a particular limit, it shows that will act only as the fillers. That won't contribute anything to the strength performance or the durability performance beyond a particular limit. So we have considered around 1,200 kilogram per meter cube in order to achieve 150 concrete, and the cement content is around 900 kilogram per meter cube to achieve this. Then to achieve the high performance concrete, I think without fiber, we got the results up to 110 MPa without the fiber. When we compare the strength parameters, I have shown one table to compare the normal concrete, high performance concrete, and the ultra performance concrete. When we say the major parameters we got when we compare the normal concrete and the UHPC, the strength parameters is too high, and including the modulus of elasticity. Okay.
Any other questions?
Okay.
So, ma'am, it was very wonderful session. So, thank you for accepting our invitation and sparing the valuable time to be with us today. Thank you.
Thank you. Thank you all.
Dear participants, the next session will start at 7:30 p.m.
Yes, one next week.
അമ്മൂമ്മയുടെ അരി കൊണ്ടുവന്നുണ്ട് കേട്ടോ വേണമെങ്കില്. പ്ലമ്മിന് എല്ലാത്തിനും ഇപ്രാവശ്യം ബൈ വൺ ഗെറ്റ് വൺ ഫ്രീ ആണ് എല്ലായിടത്തും. അല്ല പൊതുവെ എല്ലായിടത്തും. അത് കാരണം കൊണ്ടാണ് ബുദ്ധിമുട്ട്. അതെ.
such a logical
Hi all. Am I audible?
Yes, ma'am.
Okay, thank you. Good evening, everyone. I'm Asha Devasikuti, Assistant Professor, Department of Civil Engineering, and I will be the host of second session of today's program. Now we move on to the second session, which will be handled by Dr. Reshma T. Wilson. On behalf of the organizing team, it is my pleasure to warmly welcome you, ma'am, to this session. Before we begin, let me briefly introduce today's distinguished resource person. Dr. Reshma T. Wilson is an accomplished urban planner and disaster risk reduction specialist, currently serving as assistant professor and head of Department of Planning at NITT School of Architectural Planning and Design, Bangalore. She holds a PhD degree in urban planning from BNIT Nagpur, with research focusing on wetland conservation, flood resilience, and GIS-based urban planning. She has also worked with the Kerala State Disaster Management Authority, KSDMA, contributing to risk-sensitive land use planning and climate adaptation initiatives. She was recently invited as a keynote speaker at 73rd National Town and Country Planners Conference, where she addressed the theme Blue Green Economy for a Resilient Future. After this brief introduction, I'm confident that Dr. Reshma T. Wilson is a perfect person to handle today's session, and I am sure all participants will gain new insights and valuable learning from this session. Before we begin, I request all participants to kindly turn on your cameras for a group photograph. Is it okay?
No, ma'am.
Okay. Thank you all. Now I request all participants to mute your microphones and turn off your cameras to ensure a smooth running of our session. Ma'am, I now invite you to begin this session. Over to you. Thank you. Thank you. Thank you all.
So good evening, everyone. Am I audible?
Yes, ma'am. Yes.
So thank you very much for the kind introduction.
Thank you, ma'am.
So I'm really happy to be a part of this FDP and to interact with all of you today. So I'll start the session now. I'll be switching off my video to avoid any glitches and we can have a smoother session. I'll share my PPT now. Are you able to see this?
Yes, ma'am.
Shall I start?
Ma'am, can you change into slideshow?
Okay, yes.
Okay.
Now?
No, ma'am. Yes.
Wait, because it's little time it is taking. So
yeah, now it's
is
okay, ma'am.
Okay. So once again, thank you for inviting me for this faculty development program on disaster management and resilient infrastructure. I'm so happy to be a part of this since my interest in revolves around this disaster risk reduction, climate resilience, environmental planning, and urban planning. And I really tried to include civil engineering part into this since my bachelor's degree in civil engineering. What I would like to do today is, I just want you to go through how disaster actually happens, like basics of disaster and Indian context, why early warning system matters, how institutions like NDMA, SDMA functions on ground. And before we move into institutions and technologies, it is essential that we established clarity on the basic concept of disaster, disaster risk, and disaster management cycle. How many times have we heard the phrase natural disasters? Most probably countless times. But here is a thought: is disaster really a natural, or is it something we slowly create over time through our decisions, or it is always commonly called as a man-made? Disasters are often described as natural events, but from an academic and governance perspective, it is inaccurate. We start with basic, because unless we understand what disaster truly is, early warning system may look like just another technical issue. So before getting into disaster risk, we want to understand what a hazard is. We usually call hazard as a physical trigger or a physical event. Think about any normal day. Rainfall is something we welcome. It fills our reservoirs, support agriculture and the groundwater, but some rainfall can become dangerous. So hazard is simply a potential harmful event like rainfall, cyclone, any earthquake or heat waves. If a cyclone occurs in the middle of an ocean and does not affect anyone, would we still call it a disaster? So then the question comes as, what is a disaster and what is a hazard? It is important to emphasize that hazard by itself does not automatically lead to disaster. So here you can see the equation. Disaster risk is directly proportional to hazard, vulnerability, and exposure, and indirectly proportional to coping capacity. If we can improve the coping capacity of a city, we can reduce the disaster risk. How much hazard is increasing, vulnerability is increasing, exposure is increasing, it may increase on the disaster risk. So this disaster risk is really about probability, like probability of losses. Risk is not fixed, it is dynamic. By this formula itself, we can understand it keeps on changing as the hazard increases. Hazard may increase because of this land use change or this climate pattern shift. Nowadays, we are all facing the same issue with the climate change. And the vulnerability, it keeps on changing as cities grows. And few terms we are relating directly to disaster risk are urbanization, climate change, environmental degradation, continuously modify risk pattern. For a small example, rainfall events that were manageable decades ago now causes urban flooding due to increased impervious surface and reduced drainage capacity. There comes the role of a civil engineer or a planner or an architect. So can we really manage this disaster only after they happen? Or do we need to manage the risk before the disaster happens? And this is the disaster standard definition of a disaster by Disaster Management Act 2005. Now let us build on that thought. A disaster happens when a disaster meets people or infrastructure or the system that are not prepared to cope up with. Going back to this, if the disaster is increasing when the coping capacity is less. So we often explain this using a simple relationship by disaster depends on hazard, disaster directly depends on vulnerability, disaster directly depends on the exposure. Now, have you noticed how the same amount of rainfall today causes more flood than it was 20 or 30 years ago? This is not because rainfall has suddenly become dangerous. The same rainfall, same amount of rainfall, but because of our exposure, because of our increase in vulnerability, this rainfall becoming a disaster nowadays. This understanding shift our focus from nature to governance, planning, and preparedness. So, before going into detail, most of us are familiar with this disaster management cycle, which can be of two major phases. One is pre-disaster and the other one is post-disaster. Pre-disaster, which includes prevention, mitigation, preparedness, and the post-disaster, which includes response and recovery. In the previous session also, the resource person explained in these terms, but I'll go on small glimpses on this preparedness, which means to prepare for managing the crisis. Crisis may be flood, crisis may be landslide or earthquake or cyclone, any of the disasters we can take. Preparedness is something like to prepare for managing the crisis. Prevention is to minimize the impact of future disaster, or mitigation is reducing the impact. If it goes to the post-disaster, once the disaster happens, we have two stages. One is response, immediate stage, work to save lives and minimize immediate impact. And the other stage is recovery, as the later on stages to restore activities and services. Now, the interesting thing is, now everyone is focusing heavily on response and recovery. Why? Because they are visible. But my point, at what stage do we actually have the maximum opportunity to save life? The answer is the pre-disaster stage, where the prevention and preparedness happens. And this is exactly where early warning system fits in. But they directly influences the response system. An effective early warning system ensures a smooth transition from preparedness to response on timely basis to reduce the scale of loss. There comes the importance of early warning system. And now let us look at India disaster management, how the institutional setup it is acting in India. So it is organized in India. Now this slide is very important because once we understand this structure, many success stories and failure stories immediately start making sense. Think of disaster management in India as well-defined chain of responsibility. You can see it in the flow chart rather than a random emergency response. India usually follows a three-tier institutional system supported by a specialized response force. So I'll go with each stages. Now start with the top level. It is NDMA, which is National Disaster Management Authority, commonly called as NDMA, chaired by Prime Minister. Now, NDMA is not a firefighting agency. What it does is, it is not rushed to disaster site with rescue equipment. Instead, NDMA does three important things. It frames all the policies and guidelines. It prepares National Disaster Management Plan. It coordinates with scientific agencies and states. So, think of NDMA as a body that sets the rule of the game. It decides how disaster management should be done across the country to the state level and to the national level, district level. So after the national level, we'll move on to the state level, which is State Disaster Management Authority. Everyone knows each state is having Disaster Management Authority. Kerala, we have Kerala Disaster Management Authority. Each state, they will be having their own Disaster Management Authority, chaired by Chief Minister. This is where things start becoming more operational. SDMA take national level guidelines from NDMA and warning and translate them into the state context. This is what the major role of State Disaster Management Authority. And they activate State Emergency Operating Center and coordinate departments like police, revenue, health, public work, water supply, power. So why does disaster response quality vary so much from state to state? The answer is very simple. It is how the active SDMA is before a disaster occurs rather than after the disaster occurs. Now, after the state level, we have a district disaster management authority at the district level, commonly called as DDMA, usually chaired by the district collector. And what their major role is, they will be having the evacuation orders, they will be issuing the evacuation orders, they will be providing and opening that camp or shelters for the people, affected population. Warnings reach people is through DDMA. Local resources are mobilized by DDMA. Even the best forecast in the world is useless if the district administration does not act on time. So the major role comes under District Disaster Management Authority. Supporting this entire structure, we have NDRF. Almost everyone is familiar with the NDRF, National Disaster Response Force. They are trained especially for flood rescue, cyclone response, collapse structure rescue, chemical and industrial activities. So again, here there is a discussion on early warning and institutional coordination should go hand in hand. And in the last decades, India has experienced several major disasters. In how many of these cases did we actually have some form of warning? Either in the Uttarakhand flood, Chennai flood 2015, Kerala flood 18 and 21, any other disasters where we can see that actually we have given the warning and it got failed. Often the issue is not absence of warning, but when happens after the warning is issued, what will happen after we issued the warning? If scientific forecast exists, why do this disaster continue to cause severe damage? You can see 75% of the district in India is disaster prone. 12% of land is flood vulnerable area. 5,700 kilometers of coastline is prone to cyclone and storm surge. Himalayan belt is always severe towards the landslide and earthquake, and increasing heat waves and urban floods. So if hazards are inevitable, why are disasters still catastrophic? So comes what is an early warning system really? When we say early warning system, many of us imagine as a siren or as an SMS message or as a weather forecast. But an early warning system is much more than that. It is a comprehensive decision support system and a response system. It includes, you can see it in that image right side, it includes hazard detection through sensors, risk analysis, communication of warning, and activation of predefined response mechanism as a response here. After this alert, we will be getting the response is important. Its primary function is to provide time for informed action before the disaster strike. If a warning is issued, but nobody knows what to do next, is it really an effective warning? No. That's exactly why early warning systems are not just about issuing alert, but clearly defining actions and responsibility. So an effective early warning system helps to detect threats as early as possible, evaluate the risk level, deliver clear and multi-channel alert, activate predefined emergency protocol, and they are essential in managing both natural disaster or technological hazards like chemical leaks, industrial failures, and nuclear emergencies. So what are the core components of an EWS? We have same which we discussed in the previous slide, monitoring and detection, data analysis and risk evaluation, where system analyzes incoming data against configural threshold, where minimum and maximum value is managed. When danger levels are exceeding, the system initiated alerts and response protocols. And the alert communications are delivered quickly and clearly through electronic siren, maybe LED message boards, radio frequency signals, or through SMS and mobile apps, integration with civil protection platform. Once it is done, the next stage should be the activation of response protocol. Once it is triggered, the early warning system activates emergency plan like evacuation, shelter in place, and team mobilization. Coordination with authorities and prior training ensures the response is effective. According to UNDRR, United Nations Office for Disaster Risk Reduction, early warning system stands on 4 pillars. Risks knowledge, which talks about hazard, exposure, and vulnerability. Monitoring and warning, which talks about observation, analysis, and trigger. Dissemination and communication, which talks about access, understanding, and action. And response capability talks about the plans, practice, and response. So I can easily connect it with the daily use material. Imagine a chair with 4 legs. If one leg is weak, the chair will get collapsed. Similarly, a perfect forecast is useless if communication fail or if institutions are not ready to respond. This highlights the need for coordination between scientific agencies, governance institutions, and communities. So why partial system fail? Maybe because of the forecast without dissemination, maybe warning without evacuation, and maybe technology without trust. Again, previous slide, we discussed about the institutional setup. Here, I just want to discuss only about the roles of National Disaster Management Authority, State Disaster Management Authority, and District Disaster Management Authority. What is the role of these 3 organizations and what is the role of National Disaster Response Force? Coming to NDMA primarily look at policies, guidelines, and national coordination. Think of NDMA as setting the rule for the game. It does not play on the field, but without rules, the game cannot function. So the major role of NDMA is to set the rules. Then comes to the State Disaster Management Authority, takes national level warning and translate them to state level action. They coordinate with different departments as we discussed prior and activate emergency operations center. And the variation often reflects differences in state level preparedness. So state should be prepared enough to act for this warnings. And next coming to District Disaster Management Authority, which is DDMA, where things actually happens, operates at different district level, usually under the leadership of collector. This is where evacuation order is issued, shelter opens, and warnings reach people. And they will be coordinating with police, fire, health service, and all. And for all these 3, we need a strong response force, that is National Disaster Response Force, is India's specialized disaster response force. They are trained for flood, cyclone, collapse building, and other emergencies. And the key point to remember here is NDRF is most effective when it is deployed early based on warning, not after the disaster has already caused damage. So very point when we came to know that disaster is going to happen, the very next thing we should do is deploying this NDRF team to reduce that impact of disaster. And early warning systems are generally managed by agencies like IMD, Indian Meteorological Department, CWC, Central Water Commission, INCOIS, Indian National Center for Ocean Information Services, and ISRO, Satellite Indian Space Research Organization. What are the roles for this? IMD will be giving us the rainfall details, cyclone, lightning warning. CWC will be giving the flood forecasting with the water levels of each river streams. INCOIS they will be giving a tsunami early warning system. ISRO will be providing disaster monitoring and satellite data. How this warning is reaching people is, once it is detected, it will go through NDMA, then to SDMA, then to DDMA, and then it goes to community. This hierarchical flow ensures the consistency of messaging, legal authority to act, and clear accountability. And coming to the warning dissemination channels, we have major 5 different channels to last mile connectivity. Coming to here, first one is CBS, Cell Broadcast System, which we call it as a best practice. No internet required, instant alert to all phones in a geographical area, avoid network congestion, and being scaled up nationwide in India. The next is SMS alert, used by IMD or the state government. Support multi-language alert. Maybe you can use your local language over there. Limitation is it delays during network congestion, which we can avoid in cell broadcast system. Then the other third one is TV and radio, effective for mass communication, especially important for elderly and rural population where they can't use this smartphones and all. Then next channel is sirens and public address system. Mostly we can see it in coastal and flood prone areas, critical for nighttime emergencies. Best practices we can see in Odisha cyclone siren network. And the last one is fisherman alert system, which include voice message plus text alert, used extensively for cyclone and tsunami warning. This is done by the INCOIS led coastal communication model. Now, we came across what is disaster, how we can address the disaster through different institutional mechanism. What are the different disasters occurring in your state? Then what is early warning system, how it works, how it fails. Now I want to put it forward the success stories where we can take up the best practices and we can implement in your own study area. Odisha cyclone management is internationally recognized as a best practice. They had 2013 cyclone and 2019 cyclone. It is classic example of how learning from past disaster saves life. After the 1999 super cyclone, Odisha, what they did is invested in early warning dissemination, cyclone shelter, and community training. So this early warning, mandatory evacuation, cyclone shelter, trained community volunteers, and pre-positioning NDRF team drastically reduced the mortality during cyclone in 2013, Pilin, and the cyclone in 2019, Foni. This success does not come from the technology alone, but from the trust, drills, and institutional memory. So here I have given the details of how the early warning system did in Odisha and how the institutional response system. So early warning system accurate cyclone track, accurately did the cyclone track and intensity forecast from the IMD 5 to 7 days in advance. The clear communication of when, where, and how it happened. And there the National Disaster Management Authority issued national advisories. Immediately, State Disaster Management Authority activated EOC. District collectors issued mandatory evacuation orders. And in that time, National Disaster Response Force battalions pre-positioned before landfall. And over 8,000 multi-purpose cyclone shelters, clearly mapped evacuation routes, community volunteers trained annually, repeated mock drills create public trust. And outcome was 2013 cyclone pay, 1 million people evacuated, death toll was less than 50, And in 2019 cyclone, one of the strongest cyclone in decades, minimum casualties related to intensity. This is a best example for the how early warning system and the institutional setup can reduce the casualties of any disaster. Key lessons: our technology alone did not save life. Institutional memory, drills, and trust mattered most. Repeated disasters improved system and reduced mortality. And this demonstrates how policy learning, planning, and community engagement create the resilience. Coming to the next success story, which is the Ahmedabad and Odisha heat wave early warning system. Cities like Ahmedabad introduced heat action plan after experiencing several losses. Simple measures they've taken as warning, public advisories, our work hour changes, especially for the outside workers, saved thousands of lives. In 2010, Ahmedabad recorded more than 1,300 excess deaths due to extreme heat. At that time, heat wave were not treated as a disaster. And you just think from your perspective, how many of our cities treat heat wave as seriously as flood or cyclone? And what they did is, they developed a heat action plan, temperature threshold linked to color-coded alert. Just like flood, we have different color code, red, orange, yellow, and green. Like that, they had color-coded alerts. Forecast-based warning issued 3, 4, 5 days in advance. And how the municipal corporation coordinated with health, labor, education department, alert triggered the public advisories, work hour modification, school schedule changes, emergency water and cooling measures. And apart from that, they started community level actions such as awareness camps in slums and outdoor worker communities, simple behavioral messaging like drink water, avoid peak afternoon exposure, recognize heat stress symptoms. This triggered the people about, they were aware about the heat wave and they started avoiding all these things. Outcome of this was over 30 to 40% reduction in heat related mortality. Heat wave defined from weather inconvenience to public health emergency. It is not just a weather inconvenience. They made it into public health emergency. Model replicated across multiple Indian states. Now I can proudly say that Kerala started doing the heat action plan for the past 2-3 years. And this can be applicable in any of the states. So key lessons as early warning are not only for the sudden disasters. Low-cost information-based interventions can save thousands. Strong example of mainstreaming early warning system into urban governance and public health. As soon as we are going with the success story, I would like to point out the failure stories and the lessons which we can take out from, sorry to say 2018 flood as a failure story, because we had a huge loss. So Kerala flood 2018 show us that the forecast alone are not enough. We had a proper forecast, but it highlighted failure in coordination rather than forecasting. Rainfall warnings were available, but dam management and communication were poorly coordinated. But interestingly, what was the key point was community-led rescue effort partially compensated for institutional gap, especially the fishermen stepped in and saved life. But this tells us something important. Strong communities can compensate for weak system, but system should never rely on that. So what happened there is IMD issued heavy rainfall forecast, CWC monitor river levels. However, forecast was not integrated with dam opening. So there comes the institutional failure. 400 deaths, massive displacement, economic loss across the sectors. And the next disaster is Uttarakhand disaster, which is an example of what happened where there is no early warning at all. Here, there was no monitoring, no alert, no time to react. Sudden glacier collapse in the fragile Himalayan ecosystem. This case reminds us that in fragile environment, absence of early warning can be a disaster. No monitoring, no alert, and high-risk infrastructure development resulted in catastrophic losses with no reaction time. So institutional gap, no real-time glacier monitoring, no downstream siren or alert mechanism, and infrastructure planning ignored extreme risk scenarios. So it altogether became a disaster. So the lessons from this case study is absence of early warning system converts hazard into a disaster. So you can see in this images how the infrastructure planning without hazard assessment is dangerous. Himalayan regions demand precautionary, risk-sensitive planning. Here comes the role of what architects, civil engineers, and urban planners. So I just want to integrate best practices and the failure stories. What works well is successful early warning system, multiple agencies, single message. Even if multiple agencies, it should be a single message. Forecast plus decision protocol linkage should be there. Reductant communication channel, regular mock drills, and community trust. Best example also we discussed. On the failure mechanism, a second, something it is coming. The failure observed due to forecast not linked to operational decision, delayed dissemination at district level, over reliance on digital platform, poor interdepartmental coordination, which we can see in Kerala flood as well as the Uttarakhand disaster. And early warning does not lead to timely action as a failed warning. Something happened. So, is it moving? The slides are moving or got stuck? Hello?
Yes, ma'am.
Ma'am, it's moving. It's moving.
Hello?
Yes, ma'am. Ma'am.
Yes, ma'am. Slide is moving. Yes, moving, ma'am.
Yes.
Proceed. Please proceed.
Am I audible?
Yes,
Yes, ma'am, you are audible.
Ma'am, can you make it a slideshow?
Hello, ma'am. Hello.
Hello?
Ma'am, can you change into slideshow?
Okay, okay. It again gone back. Okay, okay, second.
Okay.
So, am I audible?
Yes, ma'am. Yes.
It is not getting into slideshow. A second. Wait for some time. Yes. So, it was easy for us to take what are the key takeaways from this is, let us pause and reflect on few things. Hazards are natural, but disasters are not. Disasters are mainly because of this man-made anthropogenic activities. What we are doing, because of that, the disasters are mostly happening. And early warning systems save life only when institution acts on warning. We got this from the failure studies, and governance, coordination, and preparedness matter more than technology alone. So, what is the last final compilation of the entire work is how this matters to a faculty, mostly a faculty or a practicing architect, planners, or a civil engineers. What it matters is, as a faculty members, as a faculty, as I am also teaching, we hope most all the participants are teaching. We shape how future professionals think. By integrating disaster risk reduction and early warning system concept into our teaching and research, we influence long-term resilience. In that, we have to go with governance understanding, infrastructure design, and planning decision. The effective of an early warning system is not tested during normal days, but judged on the worst day. So the best practices show clear command chain, prepared district, community trust, and failure stories reveal the fragmented governance, poor last mile communication, and ignoring the environmental limit. So how often do we discuss the disaster in our regular curriculum outside of emergency situation? So as a faculty, we can include these things in your teaching, like risk informed planning, shaping future engineers and planners, and bridging science, policy, and practice together. So to conclude this, I know it is only half an hour. It's more than the time is yet to be there. We will have a discussion rather than taking session, because this area, it is more interactive session. So we will have a detailed discussion on this. So before concluding this, I want to tell you one more thing. Early warning system are not only about technology alone. They are about the people, planning institutions, and the trust we are making. So I hope you are clear about this and we can have a interactive session now. Please.
Ma'am, can you hear me, ma'am?
Yes. Some glitches it is coming. Whether you will... Hello?
Hello. Yes, ma'am.
Here it is getting delayed. Your voice is breaking. Maybe my... एक second. I'll check with my internet. Okay. Yes.
Ma'am, like for an effective early warning system, what will be the key components for that? Can you please discuss on that, ma'am?
Yes. Again, my... So here in this slide, I have already mentioned about the core components of an effective warning system. Effective early warning system. So before going into detail about the components of the early warning system, what is early warning system we should understand. So it is a combination of detection, analysis, and alert, and after that alert we should have a response. So each stage we should explain in detail. What is detection of that disaster, how to detect whether the disaster is going to happen. So to detect threats as early as possible, it is a positive sign. If I can detect a earthquake 5 hours back, then I can easily go with the analysis and I can easily go with the response. So I can give the alert to the people, or the flood also the same way. For that, we are taking help from the organization which I've shown here. So these organizations like IMD, CWC, INCOIS, and ISRO, they will be providing us the alerts like rainfall data. They will be giving us the rainfall data, consistent rainfall data. They will be giving the water level rise. CWC is flood forecasting. So in COIS, they will be giving the tsunami. So next part is, once the detection is done, monitoring and detection, which includes seismic, chemical, meteorological infrastructure sensors. Next thing is data analysis. in that data analysis will be systems analyze incoming data against the configurable threshold. Threshold means maximum value or the minimum value. If the sea level rises more than 2.5, we should give the early warning system. We should give the alert to the people. If rainfall is coming to orange alert, if the rainfall is coming to orange alert, the people should be prepared enough to evacuate from their places. So like that things, it will come in the second stage, that is analysis stage. Then from the analysis stage, alerts are delivered to the people through quick mode, where we can go with siren sometimes, or radio frequency signals we'll be doing, or else SMS or mobile application. Then that alert, they have to take it to the people, and through that alert and the emergency plan, we should take the evacuation. We should take the evacuation routes. We should take the shelter in place, which means we should identify the camp prior. So we will take that affected population to the camp, and the emergency we should give. So these are the major stages of early warning system. Once this is done, this is the stage, and each stage they should have an coordination with the institution. Each stage means first the detection, we should have the coordination with the IMD, CWC. Then for the analysis, we'll be helping it with SDMA team. Then alerts also given by the SDMA. Then the response will be given by the other people like police. They will be taking care of health sector. They will be taking part on this. So response will be having the other institutional setup. So this is the major component of an early warning system and how it can be effectively used in any of the states.
Okay, ma'am, thank you.
Clear?
Yes, ma'am. Few more questions are there in chat box. Let me read
Okay.
and you can clarify it now. Okay.
I'll only open here. Let me check with.
How reliable? That's the first question.
One second. So how reliable are community-based monitoring system compared to sensor-based system? So for anything, community-based monitoring system have some sort of disadvantage compared to the sensor-based system. So everywhere we can't go with the community-based monitoring system. And I am not sure what he or she is asking question, community-based monitoring system in what sense? Can you please clear it out? Then I can easily help you out in answering. What the person thought about the community-based monitoring system. Hello?
Ma'am, I think community-based monitoring system, she might think about from local people, we collect the data about the history of that place.
Yes.
Yeah.
Then in that case, I don't think we should rely on that because in earlier ages we would all rely on the community-based monitoring, but compared to community-based monitoring, sensor-based monitoring is well established one, since we are doing so much of iteration to make that data, and we are depending on the data of what we are getting from the organizations. Like here I have shown, a second. Here, this technology and information. So in my opinion, sensor-based system is more reliable than the community-based system. So the next question is, what is the role of community participation in strengthening disaster response system? So very good question. So the role of community participation, we will say that it is the major area where we should focus more into community-based participation, which means if I want to do any disaster response team, or you can go through Atma Mitra as a response team, and there we are taking the volunteers as a community participation best practices. So the government is training the Atma Mitra team to get into this response activity, and it is a best practices. So you can refer to that Atma Mitra, and you will come to know how the community participation in strengthening the disaster response structure. What are the responsibilities divided among national, state, and local agencies in disaster response? It was already explained. I'll go through in detail. So if I want to go only with the early warning system, you can see these points. But as an institutional setup, in the initial stage, I have given that institutional setup image. So here you can see there is in the national level, the question is responsibilities divided among the national, state, and local agencies in the response system. Yes, clear. So we have 3-tier system in disaster management. So first, the top level is national level. We have National Disaster Management Authority, which is NDMA. Here, you can see the cursor, I guess. So NDMA is National Disaster Management Authority, which is headed by Prime Minister. And NDMA roles are, it frames the policies and guidelines for the entire states. It prepares national disaster management plans, and it coordinates with scientific agencies and state. So here also you can see Planning Commission, they are in touch with NDMA, Cabinet Committee on Management of Natural Calamity, Cabinet Committee on Security, National Institute of Disaster Management. All these are directly connected to NDMA. Then in the second stage, we have State Disaster Management Authority at each state level, where the thing is the National Disaster Management Authority will put up the policies. The Action Committee is the State Disaster Management Authority, will take the national level guidance and warnings and translate them into the state context. And this State Disaster Management Authority coordinates with the departments, other departments like Revenue or Water Authority, KSEB like Power, Health, Police. So then comes the next level is District Disaster Management Authority. In the last level, District Disaster Management Authority, where they will be doing all the evacuation orders are issued by District Disaster Management Authority. Shelters are provided and opened by District Disaster Management Authority. Local resources are mobilized by District Disaster Management Authority. And warnings reach people is through District Disaster Management Authority. Now, for flood, especially for flood, we are working for the local authorities. So, for flood, we have National Disaster Management Plan. State, we have State Disaster Management Plan. District, we have District Disaster Management Plan. And local authorities, we are now, next project is to prepare a local action plan for the disaster. There comes the institution. So in the last row, you can see academic institution, scientific organization, technical institution, professional bodies, corporate sectors, NGOs are one community which can work along with the State Disaster Management Authority and District Disaster Management Authority for the disaster risk reduction. I hope this is clear. If you want more clarity, I can go with. So how does an early warning system differ for natural disasters like flood, earthquake, and landslides? So the early warning system won't be changing. The warnings will be changing. So here I'll show that. So here the disaster cyclone. In the best practice, I have quoted cyclone as a best practice. not cyclone, as a management, early warning management as a best practices in Odisha cyclone. So here, early warning doesn't change from disaster to disaster. So early warning is a process where we will be identifying the issue prior stage, then analyze the issue, even if it is cyclone or if it is a flood or landslide, there is no much change from each disaster. Then comes the identification of that issue, then warning will be generated. So it is not depending on each disaster, it is depending on the what is first thing is amount of disaster happened, and the second thing is time of the disaster. So early warning system should happen immediately after the disaster occurs or before the disaster occurs. So it doesn't matter whether the disastrous flood, whether the disastrous landslide, whether the disastrous earthquake or cyclone. The early warning system should provide just before the disaster starts through the data you will be getting from the organizations. I think.
Okay, ma'am.
So if you can keep us in discussion mode, it will be good. Otherwise, it is same as what I am doing the repetition, but it's okay. If anyone can ask questions or open for everyone to share their opinion, because we, since I am from Kerala, we experienced 2018 and 2019 flood. So I can easily explain on 2018-19 flood on how we can say why I kept as a failure over here. Most of the people will say it's a success, but why I kept it as a failure, because of that, how the losses we had. So anyone can share their experience from your area. Anyone out of Kerala attending this FDP?
Yes, ma'am. Few participants are
Yes.
there from
So
other
it is
states.
open for you people to express your side, how your state is working in early warning system.
Good evening, ma'am. Myself, Sir Dr. Suhail from J&K, sir. Ma'am, NIT Srinagar, ma'am. Ma'am, as we, ma'am will be aware, all the expertise from the country have well knowledge. Our state is very vulnerable to the natural disasters. Long
Which
back from,
state you are from? Sorry.
ma'am, Jammu and Kashmir.
Jammu and Kashmir. Okay, okay.
Yeah, ma'am, I'm from the Kashmir region, ma'am. The
Okay.
mountainous terrain, ma'am.
Ha.
Ma'am, since I started my master's degree long back in 2014, there have been a series of episodes in this, whether it was 2014 floods or even after before there has been one of the disastrous earthquake in the Udi. So from coming this side of the country, we have seen the earthquakes, we have seen the floods, we have seen the landslides, which occur repeatedly in every winter season. And the national highway that connects both the cities, or we can say both the regions, Jammu and Kashmir. Apart from this, we have also seen the snowstorms, or we can say the avalanches. So, but one thing I would like to share on this platform, the situation has changed very much with the pace and the advancement of the technology, the national disaster management, the state disaster response boards, or the national disaster response boards. All are contributing in the way they can do beneficial or how whatever they can do. Especially thanks to the Indian Army that time and again contribute in such responses. 2014 floods has been the worst floods in the state of Jammu and Kashmir. Few months back, there was also a chance at that time the floods we have also seen, but we can say the situation is quite much improving day by day. The early warning system is being better. It is through the one of the key role that is being played these days is by the what we say meteorological department. Early warning systems help a lot. The casualties reduced to extent. Well, let us say the property don't matter that much. However, the early warning system, whether that is issued by the local disaster management authority or the we can say this the meteorological department regarding the slow avalanches or the snowstorms, the situation is the early warning system will play a critical role in this case, ma'am, because through my age I have seen these disasters, worst disasters of the country. but the system and the situation is trying to adapt. I cannot say has adapted. The situation, they are trying to adapt with the advancements that I can suggest on this platform, ma'am.
Okay, thank you. Anyone? Or shall I go back to the questions?
Yes,
Anyone
ma'am. We
want?
can.
Okay, I think nobody is interested to share their experience. Or from Kerala also you can share, because I shared from my point of view. Anyone can share their point of view. But now, as I mentioned, heat action plan in Kerala also, we came with heat action plan at the local level. So now one more thing I want to focus on. Kerala State Disaster Management Authority is the best among all the states, one of the best. Odisha is best, what I feel. And coming to second or third point, we'll be getting this Kerala State Disaster Management Authority in the top best authority, where they are taking up all the research in the disaster field. So I'll go back to question. If anyone want to, please raise your hand, or you can keep it in chat box. I'm so happy to hear from your side how your state is dealing with the disaster. So next question is, which question? Can you please mention about the role
Yes,
of
ma'am.
AI?
I will read out.
Huh.
May I read out, ma'am?
Can you please mention about the role of AI and machine learning in improving disaster prediction accuracy? So, remote sensing, we all know it is a detection and monitoring tool. If I want to go in detail, what exactly the remote sensing and GIS is talking about? No, role of AI and machine. I wrote, okay, sorry. It was two different questions. This question got stuck. Can you please read out
Yes,
Anjali
ma'am.
Rajan?
Yes, ma'am. I will read out. Can you please mention about the role of AI and machine learning in improving disaster prediction accuracy?
Okay. AI and
Machine learning. Yes, ma'am.
So, and learning in improving disaster. So, artificial intelligence
Disaster
and machine.
prediction.
What? Improving disaster prediction.
Prediction, yeah, accuracy.
So nowadays in AI is using, especially AI is using in early warning system to improve the prediction, and how it is going with this physical based model, explain how a disaster may happen. And AI model learn how disaster usually unfold in real world condition. So this is the major difference between the AI and physical based model. So coming to the key role of this AI and ML in disaster early warning system, we think the improving the prediction accuracy. So AI model analyzes the historical disaster records, weather and hydrological data from the organization, and they will connect it with satellite imagery, and AI will connect it with the land use and terrain, then helps to reduce the whatever, whether it may cyclone track, error or rainfall and flood forecast, and false alarms in landslide. So most reliable and confident warning we will be getting through AI, and it is an increasing lead time. So since AI can process large data set much faster than the conventional simulation method, so this is crucial for flash flood. Flash flood is all of a sudden because of the heavy rainfall, the flash flood comes, or cloud burst or landslide. For this, AI can process a large data set. So which leads to less time for the prediction and more time for the evacuation and preparedness. So this is what we can use for AI and machine learning for the improving disaster. If you want in detail, I can share few papers in AI and machine learning. Hello. Sorry, some disturbance. Any doubts on this?
Okay.
So AI in response and damage assessment beyond prediction can rapid damage assessment can be used. So once the disaster happened, early warning system is post disaster stage. or in AI can be used in response and damage assessment. So by using AI tools, we can assess the rapid damage due to this disaster and identify the collapsed building because of the cyclone or landslide or earthquake, and prioritizing the rescue and relief operation. So in all together, if we are using AI and machine learning, we can reduce the time for larger data analysis, and we can take up the decision maybe little more faster. So in cut short, we can go with risk knowledge is high, monitoring can be done very fast, forecasting can be done fast, dissemination means giving that warning can be done fast, and response can be done fast. So all that we can do it in a faster pace. Next question, can you please read out? I think it is clear.
Yes, ma'am, clear.
So can you please read out the second?
Yes, ma'am. Next question, how remote sensing, GIS and IoT integrated into disaster early warning frameworks?
Yes, I can. Okay, I got. So same as remote sensing, everyone knows what is remote sensing and GIS. It's a detection and monitoring tool. And some cases we will be doing that analysis. So mainly the satellite and aerial observation over larger area, and where we are not able to reach, we can take it from remote sensing and GIS. And real-time monitoring before, during and after events, we can find it out. And what exactly we'll be using? So disaster early warning system, if I want to go with, or the vulnerability also, you can refer to one paper which I published, vulnerability assessment of Ernakulam district, where we will be inputting few data and we can find out which area is more vulnerable towards this flooding. So that is one post-disaster prevention stage or the mitigation stage. Once we understood which area is more vulnerable, we can be prepared enough to go for any response activities or this early warning system. So by providing easily getting this early signals and spatial coverage, we can easily get the ground network without any fail, and enable baseline versus anomaly comparison also, what is normal and what is changing, that we can easily do it by remote sensing and GIS. And coming to IoT, what we will be doing is ground truth in real time. What is ground truth? Which we will be local sensing and triggering. So which continuous high frequency on ground measurements and even triggers at micro scale. That is a smaller scale. We will be able to go with an IoT integration in disaster early warning framework, where we can go with river level, which I have already mentioned. CWC will be giving the data, rainfall gauges, soil moisture, temperature and humidity data. All these things we can integrate into the disaster early warning system through GIS and IoT. If you want in detail, I can share the papers related to this, and it should be explained in detail to understand how we can use remote sensing GIS in early warning system. Simple way is, for anything, step by step is, for first thing is to detect this thing. So by using remote sensing, it is easy to spot the regional changes. IoT sensors also record local threshold, like soil saturation or river rise. Then next stage is validation, where validation also we can use IoT, confirm satellite detected anomalies. Then for the analysis, the next stage is analysis, that we can go with the GIS overlaying method, which I think you people are known about this overlay method. We will be doing that overlay by NDBI, all this topography map overlay. By using this overlay analysis, we can go with the exposure and vulnerability. And for decision making, we can go with dashboard showing who, where, and how severe the disaster will be. So we can go with a detailed SOP for evacuation, closure, and deployment. And last stage is dissemination. So in the dissemination, we can go with community and disaster action activated through this GIS and IoT. Identification of location, all these things, we can use this GIS and IoT. So this is the different stages we can use the GIS and IoT in disaster early warning framework. What next question?
Ma'am, hello.
Yes. What is next
Ma'am,
question?
how we can done this early warning system in lab setup for detecting landslide or soil piping? We can implement this.
No. So this early warning system, the data we should get it from the organization which I have already mentioned. So I'll go through that. Yes.
Ma'am, in case, hello.
Please. Please. Hello.
Yes, ma'am.
Yes. Go forward.
Okay, ma'am. In case of soil piping or internal erosion, we can get the data from the properties itself. So with that data, we can do.
Yes. Data we will be getting. That's what I explained the stages. So as an institution, what we can do as a faculty, what we can do is we can implement a curriculum in the teaching field, or we can go with the research cell. We can't set that early warning, or else we should go with that this second here. These are the major 3 stages: detection, analysis, and alerts. Detection also, you can go with analysis part. If you are getting data for flooding, if you are getting data from IMD, now the detection and analysis is done by SDMA. So as an institution, you can take up that analysis or detection stage to get that analysis saying that this area will get flooded in 3 hours, or this area will get it flooded in 5 hours. That analysis you can do from your lab or your facility. Then you can share the data to SDMA. The government only should give the alert. As an institution, as an organization, private or this educational institution, we can't get an authority to give the alert to the people. So this analysis part or the detection part, you can do it in your lab.
Okay, ma'am.
So if you are getting data for water level, we will be getting data from CWC. So CWC website say you can get, if you are since your college is in Thrissur, every water body's water level during monsoon, they will be giving that water level. So next stage, as a civil engineers, you can find out how much water will get increased because of this continuous rainfall in 1 day or 2 days or hours may. If you can get that analysis done, you can give that analysis to the organization DDMA or SDMA to provide the alert. They will look into this, because since the same analysis we are doing in SDMA, so I don't know how well you can do it in your organization. So in SDMA, what we used to do is we will be finding out the water level at every 1 hour during the high peak hours of rainfall. Then we will be sending the alerts to the people. So as a research institution, you can find out any analysis method or detection ke liye, any method you can find out by using AI/ML. Then you can give the data to the organization. From the government organization, they have to give the alerts.
Okay, ma'am. Thank you.
Okay. Same with the soil piping also. Soil piping, I'm not an expert, so I can't give you more into soil piping, but this landslide,
Okay, ma'am.
I
Our
worked.
students are doing analysis of the soil piping and mapping using QGIS. So that's why I asked you, is there any option to get this early warning system of soil piping? Actually, they collected the soil from one landslide prone area in the Thrissur itself.
Okay.
And in the permeability apparatus, they are setting up the soil piping process mechanism.
Soil piping, I don't think soil piping ke liye we can give that early warning alerts. But what you can connect it with, the soil piping vulnerable areas, you can find it out because of this different parameters. First, you can identify different parameters which leads to soil piping. Maybe the soil moisture, soil condition, maybe the terrain of that area, vegetation of that area, all this you can get it in QGIS. Then overlay that and you can find out which area is more vulnerable towards soil piping. That we can find out, but early warning, I don't think we can go with alerts. We can go with, but what you can suggest is if there is a place where soil piping is high, what precautions people should take. Like flooding area, if I have a land of 10 acres full of flooding area, but I want to construct something over there. So as a civil engineer, what I can suggest is, I can go with flood resistant building construction over there. So what I feel as a proposal, you can share what precaution the people over there have to take of this soil piping.
Okay,
Other
ma'am.
than early warning system, I'm little confused. If I'm getting any papers, I'll share with you.
Now what we finalized is just to analyze the piping and then like mapping using QGIS, like what the prediction of occurring this piping in that area. So like that, what we finalized now, and if there is time, then one remedial measure also to resist this soil piping.
Remedial measure will be fine, but if you can go with some sort of risk informed master plan, what we usually call as a master plan with risk informed activity. So like that, for the soil piping, what are activities they can keep for mitigating the soil piping, which
Okay,
means
ma'am.
reducing that impact of soil piping. We can't
Okay.
prevent that soil piping, we can reduce the impact. Yes, so if you can provide that guidelines, then you can submit that guidelines to the authority also. I think so. Organization where SDMA itself, you can submit that, or else framework. As a framework, you can prepare a framework that can be useful for any of the states. If it is a low laying area, if it is high laying area, like that, if you can make a framework, then that can be useful for any of the states. You can present one paper also, I guess so.
Okay,
But early
ma'am. Thank
warning
you so
system,
much.
I'm not sure about the soil piping. So sorry.
No, okay, ma'am. Thank you.
So any other question?
Ma'am, I hope questions are over.
Any one want to discuss on this early warning system, share their views on this?
Those who have any doubts, you can ask now or share your experience or real world examples. You can utilize the platform now. Okay, ma'am, I think no one has a doubt.
Okay, should we wait
Oh,
or we can?
okay, ma'am. Anyway, thank you, ma'am. Thank you so much for the enlightening and well-structured session. You really well executed the session with real-world examples and case studies, which involve both success and failure stories. So on behalf of organizing team and all participants, I sincerely thank our esteemed resource person, Dr. Reshma Vilasan, for providing valuable insights and a deeper knowledge understanding of the subject, early warning system, disaster response structure. We sincerely appreciate your time, effort, and willingness to share your expertise, which greatly contribute to the success of this session. Thank you once again, ma'am, for your esteemed presence and contribution. Thank you, ma'am.
Thank you very much. And I am so thankful for you, entire team, to give me an opportunity to express my interest. And this is my interest area. So if we can collaborate later on, I am so happy to collaborate on this disaster related studies with the civil engineering department. So,
okay, ma'am.
Thank you.
Okay, ma'am. Thank you so much. I also thank all the participants for your active involvement and cooperation. So with this, we come to the end of today's FTP session. I hope this session has been enriching for everyone. So thank you all. So I think feedback link has been shared in the chat box as well as through WhatsApp group. So everyone kindly stay here and fill the form. Okay. Thank you. hope everyone fill the feedback form. So now you can leave the meeting. See you all tomorrow. Thank you.